The world has a population expected to hit a whopping number of 9 billion by 2050. What's expected to follow is a dramatic rise in agricultural production, doubling to meet the coming demand. This need is caused by farmers to turn to robotics as solutions for the coming future. Now, you have probably heard how people across various industries are using robotics to disrupt their respective industries. Customer service, packaging and shipping, manufacturing, and transportation of all these industries soon to be hiring more robot employees. Nevertheless, the growing population, rise of AI, and new developments in robotics has caused the world of agriculture to explode with innovation. From nursery planting to herding, here are some robots that are already in agriculture. Before that, make sure to subscribe to our channel, support us on Patreon, and the link is down in the description. Number 1. AGROBOT. AGROBOT is a harvester equipped with a set of robotic arms whose movements are managed by an AGB system that analyzes the fruit one by one and is responsible for ordering the precise cutting movements that guarantee accuracy, smoothness, and the delicacy of a strawberry's treatment. This is possible thanks to its optical sensor AG-Vision, an artificial vision system that implements a real-time protocol for morphological and color analysis to identify and select the fruit based on size, external quality, and degree of maturity, according to the quality standards set by the farmer. The robotic arm ends in sort of a rubber-lined basket with thin round plates as razors for removing the fruit. Once picked, the strawberries are placed on a conveyor belt and hygienically moved to the packaging area, consisting of 2 ergonomic workstations where an operator can immediately select and pack fruit. The all-wheel drive SW comes equipped with a high efficiency and low fuel consumption motors, and a 2-cylinder diesel engine that creates up to 28.5 horsepower. The machine is insulated to reduce noise and vibration. AT-Cross is a revolutionary navigation system that integrates a guidance and automatic operation system, AGM, providing fully independent control of the main functions of the harvester. Coming in at number 2, Rocos. Spot, a mobile robot designed to go where other robots can't, can now be easily operated from a remote location. This is made possible through a new partnership between robotic software operation platform Rocos and Boston Dynamics, the company behind Spot, according to a news release. Rocos will provide remote mission design and execution as well as teleoperation functionality for the durable, customizable robot. With the Rocos software, missions can be designed and edited on the fly, and remote teams can access data collected during the missions. Teams also can manually operate Spot to investigate issues, capture new data, or redirect the robot if needed. The robot travels through rugged environments, capturing data in real time and feeding the data back to existing business systems. This can be useful in a variety of industries, including energy and agriculture. A 4-legged robot trots around a grassy hillside, steering a herd of sheep without a human in sight. The apparently seamless fusion of futuristic and traditional is refreshing, even hopeful, at a time when so much progress relies on the destruction of the natural world. Coming in at number 3, Meat to Motion. Grow, Greenhouse Robotic Worker, is a multi-purpose robotic system for labor-intensive tasks in the greenhouse. Grow's first application is a selective robot harvesting of greenhouse tomatoes. Grow is designed for a simple operation and smooth integration into existing greenhouses, infrastructure, and practices. It easily adapts to perform a range of greenhouse tasks, including harvesting of additional vegetables, pruning, monitoring, pollinating, and more. Meat to Motion estimates a reduction of up to 50% in harvest-related labor cost, with a predicted ROI in under 3 years of the grower. The system is designed for easy operation and smooth integration into existing greenhouse practices. The harvester will significantly reduce the number of workers needed for vegetable production cycle, 1 operator for 5 harvesters. It will minimize fruit damage and increase production efficiency. The systems collect large amounts of data during harvesting, Analyzed data gives the growers new levels of information for improving production. Meta-motion systems can be easily adapted to additional crops in a range of greenhouse tasks, including harvesting, pruning, monitoring, de-leafing, and pollinating. Meta-motion's robotic harvester is composed of an automatic guided vehicle, multiple robotic arms, and an advanced vision system, as well as a proprietary harvesting component tailored to specific vegetables. The system is being designed for easy operation and smooth integration into existing greenhouse practices. Grow will alleviate agricultural employees from the back-breaking work, permitting them to switch to more alleviated tasks. In the context of precision farming approach, automation in the agricultural sector is particularly solicited, and Meta-motion is offering a product capable to satisfy the most compelling needs of growers. Number 4. Ripa. Ripa, the eco-friendly four-wheeled robot made to help people in agriculture, was invented by robotics specialists from the Faculty of Engineering and Information Technology's Australian Centre for Field Robotics, also known as ACFR. A built-in sensor inside of Ripa can measure soil moistures as well as soil temperature. Ripa is powered by solar energy and collected by the solar panels top of the machine. As long as there is a solar panel available, Ripa can run 24/7. A high-speed camera and remote sensing allows automatic weed removal, as well as pesticide dispersion. Ripa is mounted with a VIPA, which is a variable injection intelligent precision applicator. This means the robot can automatically be used for spraying weeds at high speeds. This is done by using a directed microdose of liquid. The robot can also follow or change rows in a vegetable field, while it can detect produce in real time. The Ripa robot also has the ability to collect data using sensors that can map any area of crop and detect weeds as well as highlight foreign objects. This is done through a number of sensing modules, such as thermal imaging, 3D structural sensing, and hyper and multispectral imaging, among others. Number 5. The Pier System. Pier System is the efficient and animal-friendly solution for collecting, transporting, and unloading poultry. Quality and food safety are some of the most important things for farmers, breeders, and slaughterhouses. Therefore, they operate according to strict standards with great care for the animals. The latter also matters to conscientious consumers we find nowadays. Poultry meat mustn't only be the best quality, but also have circumstances in which the animals find themselves while alive, have to be as good as possible. Catching poultry is in many cases still done by hand, which makes it an intensive, heavy task for employees and creates a very stressful situation for the animals. They panic and easily get damaged. Pier System investigates problems arising in both catching and transportation of poultry, as well as unloading at the slaughterhouse, and thought of a way to improve this procedure. This extended research led to one solution: the Pier System. The Pier System is a mechanized method of capturing, loading, and transporting live poultry, and guarantees a considerable matter of capturing, loading, and transporting live poultry, thus significantly improving the welfare standards. Pier System contributes to a considerable degree to a higher product quality and, in view of increasing requirements of some of our customers, who put a lot of emphasis on the correction of treatment of live poultry and check its conditions as well as the quality of poultry meat and its final products. Pier System has contributed to meeting these requirements. Pier System has lowers the cost of workforce, reduces strenuous physical work of the employees, and increases work productivity. The vehicles used by means of Pier System are equipped with ventilation, which guarantees sufficient air circulation in the course of transporting poultry. As the vehicles are equipped with an efficient air conditioning system, the transport of poultry in the summer in extremely hot weather is very animal friendly. The technology of the Pier System consists of machines for the automatic capturing of slaughter chickens on the farms, chicken harvesters, and of machines for handling chickens between the chicken harvesters and a means of transport called shuttles. It further includes the means of transport carrying the technology for the automatic loading and unloading the chickens. These are called pier trailers, and of technology on the slaughtering premises for unloading the chickens and their transport to the premises where they are shackled for the slaughter line. All the pier system machines and equipment are adapted in terms of construction to make the process comply with the animal welfare principles and to protect the poultry against possible negative external influences. It denotes the Dutch system of capturing, handling, transporting, and unloading slaughter chickens introduced in our Vodny plant. This demanding modernization has removed capturing the poultry manually and transporting it in crates. This up-to-date transport technique includes, apart from a full automation, a unique air conditioning system reacting to temperature changes. It also ensures that the poultry transported is not exposed to distressing situations, not even when transport is stopped due to an emergency. All these factors have resulted in a significant advance in quality of the raw material supplied, based on an animal-friendly manner of capturing and subsequent unloading of poultry for slaughter.